The third comma comes.
Introduction. Sometime we need to use numbers with a negative sign. The most common area is while expressing temperature. In cold regions, the temperature goes below zero and is expressed. At the end of this lesson, you will be able to define integers, explain integers on a number line, define ordering of integers, find addition and subtraction of integers, define addition and subtraction of integers on a number line. Hello students! You already know about natural numbers and the whole numbers. If we put negative numbers and whole numbers together, the collection of numbers is known as integers. This figure represents a line marked with some points at equal distance. A point on it is marked as 0. Points to the right of 0 are positive integers. Points to the left of 0 are negative integers and are marked -1, -2, -3, and so on. This type of representation of integers is called the number line representation. Here, to mark plus on the number line, we move 2 points to the right of 0. Similarly, to represent -5, we move 5 points left of 0. Let us again observe the integers which are represented on the number line. We know that 9 is greater than 5, and on number line, 4 points right of 5. Similarly, 5 is greater than 0, so placed right to it. Since 0 is to the right of -2, it is greater than -2. Again, -2 is on the right of -7, so -2 is greater than -7. Thus, we see that on the number line, the bigger numbers are placed right and smaller at the left. Addition of two positive numbers. Example. A boy is riding a ladder staircase. He goes 6 stairs up from the ground and halts for a while, then goes up 4 more stairs. How many stairs he goes up from the ground? +6 plus +4 is equal to +6 plus 4, which equals +10. Addition of two negative numbers. Example. In a game, you have to pick up any 2 pieces of paper on which a number is written. You have to add the numbers written on these 2 papers. Suppose you get -2 and -5. What is the result of addition of these 2 numbers? -2 plus -5 is equal to -2 plus 5, which equals -7. Addition of two integers. Example. Suppose in the above game you get the numbers +5 and -9 on the slips. What is the sum? +5 plus -9, which is equal to -4. Students, now we learn addition of two positive integers on a number line. If we add 6 and 4 on the number line, the first moves 6 steps to the right from 0, reaching 6, and then we move 4 more steps to the right of 6 and reach 10. Thus we get 6 plus 4 is equal to 10. Let us add two negative numbers, -5 and -4 on the number line. In this case, first we move 5 steps to the left of 0, reaching -5, and then we move 4 steps to the left of -5 and reach -9. So we see when we add two positive integers, their sum is a positive integer. When we add two negative integers, their sum is a negative integer. An ant is moving on a number line. It moves 6 points right from 0 and then comes 2 points back. Where is it at present? It will be at 6 plus -2 is equal to 4th point to the right of 0. If the same ant moves 6 points left and then 4 points to the right, then where it will be? It will be at -6 plus, within bracket, +4 equals -2. That is, second point to left of 0. Now we will learn additive inverse. Suppose the ant walks 3 points from 0 to the right side and walks back 3 points. Where does it reach ultimately? You can see that it will reach to 0. We add 2 and -2. We obtain the sum as 0. Numbers such as 3 and -3, 2 and -2, when added to each other, give the sum 0. They are called additive inverse. For better understanding, we can solve one example. We arrange the numbers so that the positive integers and the negative integers are grouped together. Now let us find the value of -10 minus -5 using a number line. This is same as -10 and +5, as the additive inverse of -5 is 5. First, we move 5 steps to the right on the number line, starting from -10. We reach to -5. Summary. Let us summarize what we have learned. The set of integer is z, which is equal to, within bracket, -3, -2, -1, 0, 1, 2, 3. On the number line, all negative integers lie to the left of 0 and all positive integers lie to the right of 0. The number 0 is less than every positive integer and greater than every negative integer. Rules for addition and subtraction of integers. 1. When two positive integers are added, we get a positive integer. When two negative integers are added, we get a negative integer. When one positive and one negative integer are added, we subtract them and put the sign of the bigger integer. The subtraction of an integer is the same as the addition of its additive inverse.
Introduction.
Anuj, let's get you some shirts. Many of your clothes have become short.
Yes, Mom, even I was going to ask you the same. Let's go to the shop in mall. That evening, Mother and Anuj visited the shop. Anuj bought 2 shirts for rupees 2,549. Her mother bought some grocery items and the bill amounted to rupees 2,350. At home, he compared the total amount of the 2 bills. He told that his shirt's cost was more than all the grocery items. How was he able to tell? It was because he learned about large numbers. Come, we too will learn about numbers. Comparing numbers. A collection or group of numbers can be compared with each other. On comparing the numbers, we can tell which group is large. The arrangement of numbers from the smallest to the largest is called ascending order. The arrangement of numbers from the largest to the smallest is called descending order. If 2 numbers have an unequal number of digits, then the number with a greater number of digits is greater. If 2 numbers have an equal number of digits, then we need to compare numbers at each position. The largest 4-digit number is 9,999. What should be added to this number to make smallest 5-digit number? The answer is, we need to add 1. Let us find out. On adding 1 to 9,999, we get 10,000, which is smallest 5-digit number. Can you guess the smallest 6-digit number? Smallest 6-digit number is 1 lakh. Digits of a number can be shifted to form greater or smaller number. Let us see how. Writing large numbers. Sometimes the large numbers are so large that it becomes difficult to keep track of. Then it helps to use indicators to read and write large numbers. In a decimal number system, the value of a digit depends on its place or position in the number. Each place has a value of 10 times the place to its right. It can be extended to crores. The chart helps in reading and writing numbers and is called place value chart. Number system. In our Indian system of numeration, we use ones, tens, hundreds, thousands, and then lakhs and crores. Comma is used to mark thousands, lakhs, and crores. The first comma comes after hundreds place, 3 digits from the right, and marks thousands. The second comma comes 2 digits later, 5 digits from the right. It comes after 10,000's place and marks lakh. The third comma comes after another 2 digits. 7 digits from the right. It comes after 10 lakh. In the international system of numeration as it is being used, we have ones, tens, hundreds, thousands, and then millions. 1 million is 1,000 thousands. Commas are used to mark thousands and millions. It comes after every 3 digits from the right. The first comma marks thousands and the next comma marks millions. Let us look at some pointer. 1 crore is equal to 100 lakhs. 1 millions is equal to 1,000 thousands. 10 crores is equal to 100 millions. 100,000 is equal to 1 lakh. Estimation to nearest numbers. As we come across large numbers, performing calculations on them becomes complex. To avoid the complexity, estimation or rounding off is used. For example, in a school with 496 students, you can say that there are approximately 500 students in the school. Rounding numbers to the nearest 10 means finding which 10 they are nearest to. For example, 23 rounded to the nearest 10 is 20. Rounding numbers to the nearest 100 means finding which 100 they are nearest to. For example, 423 rounded to the nearest 100 is 400. Rounding numbers to the nearest 1000 means finding which 1000 they are nearest to. For example, 3800 rounded to the nearest 1000 is 4000. Estimation of sum, difference, product. Estimation to nearest number can help in the estimation of the sum of two large numbers. For example, add 4780 and 3325. Rounding off 4780 would make it 4800. Rounding off 3325 would make it 3000. Sum of the two, 7800. Estimation to nearest number can help in the estimation of the difference of two large numbers. For example, subtract 22,345 from 29,664. Rounding off 29,664 would make it 30,000. Rounding off 22,345 would make it 20,000. Difference of 2 is equal to 10,000. Estimation to nearest number can help in the estimation of the product of two large numbers. For example, multiply 33,467 and 8,888. Rounding off 33,467 is equal to 33,000. Rounding off 8,888 is equal to 9,000. Product is equal to 33 into 9 followed by 6 zeros, which is 29 crore 70 lakhs. Simplification using brackets. Consider the given question. This question can be solved in two ways. Which is the correct answer? Use of brackets allows us to avoid confusion in the problems where we need to carry out more than one number operation. Let us see how. If the question would be given as shown on screen, it would be easy to calculate. Yes, the answer would be as 17 into 109 is equal to 1853. Let us simplify. This can be solved as 8 into 100 plus 8 is equal to 8 into 100 plus 8 into 8, which equals 800 plus 64, which is equal to 864. Roman numerals. We use the Hindu-Arabic system of numerals. Another system of writing numerals is the Roman system. It is one of the oldest systems of writing numbers, which is still prevalent at many places. Unlike the Hindu-Arabic numeral system, Roman numeral system uses 7 basic symbols to represent different numbers. The symbols are as follows. Look at the table of symbols. There are certain rules to form Roman numerals. They are: 1. If symbol is repeated, then its value is added. 2. The symbols I, X, C and M can be repeated maximum 3 times. 3. The symbols V, L and D can never be repeated. 4. If a symbol with smaller value is written on right of greater value, then smaller value is added to the greater one. 5. If a symbol with smaller value is written on left of greater value, then smaller value is subtracted from the greater one. Summary. Let us summarize what we have learned. Numbers can be compared to know the larger quantity. Numbers can be written in different formations. Indian and international system of numeration and the difference between them. How to round off a number to nearest whole number. Estimating the sum, difference, product using rounding off. How to simplify calculations using brackets. Roman numerals.
Introduction. Jogging in a park. The park is a square. Each side of the park is 250 meters long. You take 5 rounds of the park and return home. Your mother wants to know how many meters you jogged. Can you calculate? The concept that you need to use is perimeter. In this lesson, we will discuss the concept of perimeter in detail. Objectives. At the end of this lesson, you'll be able to define perimeter, calculate the perimeter of a square, calculate the perimeter of a rectangle, calculate the perimeter of other regular shapes. Let us now try to answer your mother's question. How many meters did you cover jogging? In every round of jogging, you covered the 4 sides of the park. Since the park is a square, all its sides are equal. Thus, in one round, you covered 250 plus 250 plus 250 plus 250 meters, that is 1000 meters. Therefore, in 5 rounds, you covered 5 into 1000 meters, that is 5000 meters or 5 kilometers. Now you're ready to answer your mother's question. In this calculation, we used the concept of perimeter when we worked out the distance you covered in one round. Perimeter is the total length of the boundary of a closed two-dimensional figure. Here is a simple technique of measuring the perimeter of a shape. Take a closed geometric shape such as a circle, square, triangle or rectangle made of string. Unite the string and measure its length. The length of the string is the perimeter of the chosen geometric shape. We can generalize by saying that the perimeter of any closed geometric figure is equal to the length of the string with which it is made. Now that you have understood what perimeter stands for, let us try to calculate the perimeter of a pentagon. We have seen that the perimeter of a geometric figure is the sum of the lengths of its sides. A pentagon is a closed geometric figure of 5 sides. Suppose the lengths of the 5 sides AB, BC, CD, DE and EA are AB as 4 centimeters, BC as 5 centimeters, CD as 3 centimeters, DE as 3 centimeters, and EA as 4 centimeters. The perimeter of the pentagon is 4 centimeters plus 5 centimeters plus 3 centimeters plus 3 centimeters plus 4 centimeters. That is equal to 19 centimeters. Let us now calculate the perimeter of a rectangle. Rectangle is a 4-sided geometric figure whose opposite sides are equal. Therefore, the perimeter of a rectangle is twice its length plus twice its breadth. We can rearrange a little and say that the perimeter of a rectangle is twice the sum of its length and breadth. We wish to plant flowers on all sides of a rectangular patch of land whose length is 800 meters and breadth is 500 meters. Calculate the total distance to be covered by flowers. The distance to be covered by flowers will be equal to the perimeter of the rectangular patch. The perimeter of the rectangular patch is 2600 meters. Therefore, the total distance to be covered by flowers is 2600 meters. Now let us work out the formula for the perimeter of a square. You are already aware that all the four sides of a square are equal in length. Therefore, the perimeter of a square is 4 multiplied by its side. Now you want to add frills to all sides of a square table mat, length of whose side is 5 centimeters. Calculate the length of the frill required. The length of the frill required is equal to the perimeter of the table mat. The perimeter of the table mat is 20 centimeters. Therefore, 20 centimeters long frill is required. Shapes that have all sides of equal length and all angles of equal measure are known as regular shapes. Square is a perfect example of regular shapes. Another regular shape is the equilateral triangle, whose 3 sides are equal. Perimeter of an equilateral triangle is 3 multiplied by its side. Suppose there is an equilateral triangle of side 3 centimeters, then the perimeter of the equilateral triangle is 3 multiplied by 3, which is 9 centimeters. Perimeter of a regular hexagon is 6 multiplied by its side. Suppose there is a regular hexagon of side 5 centimeters, then the perimeter of the regular hexagon is 6 multiplied by 5, which is 30 centimeters. Summary. Let us summarize what we have learned. Perimeter is the total length of the boundary of a closed two-dimensional figure. Perimeter of a geometric figure is the sum of the lengths of all sides. Perimeter of a rectangle is equal to 2 into length plus breadth. Perimeter of a square is equal to 4 into length of a side. Perimeter of an equilateral triangle is equal to 3 into length of a side. Figures in which all sides and angles are equal are called regular closed figures.
Introduction.
Hello, Mom. I'm here as promised. Let us go for the movie.
Vidushi, you will have to wait for half an hour. Let me complete this drawing.
It is all right, Mom. I can wait. Tell me, Mom, how do you draw these huge buildings and their interiors?
With the help of these instruments.
They are so familiar to the ones we use in geometry class.
Do you now understand how important mathematics is to architecture?
Yes, Mom, I do.
In this lesson, you will learn practical geometry. Construction of circles. A circle is a two-dimensional figure. Every circle has a center. The distance between the center and the boundary of a circle is known as its radius. The line segment through the center of a circle with its end point touching the boundary of the circle is known as the diameter of the circle. The diameter of a circle is twice its radius. We draw circles with the help of a compass. Compass is an instrument with two arms. While one arm remains fixed, the other arm with the pencil moves freely. Let us use a compass to draw one circle, two intersecting circles, three concentric circles. One circle. Let us draw a circle with 3 centimeters radius. Place the compass on a ruler and widen it to measure 3 centimeters. Mark the center of the circle with the sharp end of the compass. Move the arm with the pencil around, keeping the other arm fixed at the center of the circle. The circle is formed. All the points on the boundary of a circle are equidistant from its center. Two intersecting circles. Intersecting circles may or may not have the same radii. Let us now draw intersecting circles. Draw a circle with 4 centimeters radius. Draw a circle with 5 centimeters radius in such a way that it passes through the first circle. We have 2 intersecting circles. 3 concentric circles. Concentric circles are circles with the same center but different radii. Let us now draw 3 concentric circles with the radii 2, 3 and 4. Mark the center and draw a circle with 2 centimeters radius. Draw the second circle with the same center but a different radius of 3 centimeters. Draw the last circle again with the same center but a different radius of 4 centimeters. We have 3 concentric circles. Construction of line segment. A line segment is a measurable part of a line with 2 definite endpoints. We use a ruler and a compass to construct a line segment. Let us construct a line segment 5 centimeters long. Draw a long line M. Mark a point X on it. Place the compass on a ruler and widen it to measure 5 centimeters. Place the sharp end of the compass on point X. Rotate the other arm with the pencil to make a mark at point Y on the same line. We have a line segment XY which is 5 centimeter long. Suppose a 6 centimeter long line segment PQ is given. We want to create another line segment ST of the same measurement. How do we do it without using a ruler? Use the compass to measure PQ. Draw a long line L. Mark a point S on it. Place the sharp end of the compass on point S. Rotate the other arm with the pencil to mark point T on the same line. We have a line segment ST which is a copy of the line segment PQ. Construction of perpendicular to a line. A perpendicular to a line cuts it at right angles. A perpendicular to a line can be drawn into 2 ways. Through a point on the line, through a point outside the line. Let us learn to construct perpendiculars in both the ways. Perpendicular through a point on the line. Draw a long line M. Mark a point A on it. With point A as the center and any radius, draw an arc to cut line M at 2 points C and D. With the radius greater than CA and C as the center, draw an arc above the first arc. With the same radius and D as the center, draw another arc above the first arc. Mark the point of intersection of the 2 arcs as E. Join point E to point A with the help of a ruler. EA is perpendicular to line M. Perpendicular through a point outside the line. Draw a long line M. Mark a point A above it. With point A as the center and any radius, draw an arc to cut line M at 2 points C and D. With the radius greater than half of CD and C as the center, draw an arc below the first arc. With the same radius and D as the center, draw another arc below the first arc. Mark the point of intersection of the 2 arcs as E. Join point E to point A with the help of a ruler. AE is perpendicular to line M. Construction of bisector of angle. The bisector of an angle divides it into 2 equal halves. Let us learn to construct an angle bisector. Draw angle AOB. With O as the center, draw an arc to cut the two rays OA and OB of the angle at P and Q respectively. Measure a radius greater than half the length of PQ. With the measured radius and P as the center, draw an arc above PQ. With the same radius as Q, as the center, draw another arc above PQ. Mark the point of intersection of arcs as C. Join O and C. Measure angles AOC and COB. Angle AOC is equal to angle COB. Therefore, OC is the bisector of angle AOB. Construction of copy of angle. How do we construct a copy of an angle whose measure is unknown? Angle AOB is given. With O as center and any radius, draw an arc to cut the two rays OA and OB of the angle at P and Q respectively. Draw a long line L and mark a point S on it. With OQ as radius and S as center, draw an arc to cut line L at T. With PQ as radius and T as center, draw an arc to cut the previous arc at R. Join R to S. Angle RST is equal to angle AOB. Construction of angles. Let us now construct some special angles one by one. 30-degree angle, 60-degree angle, 120-degree angle. Construction of 30-degree angle. Draw a long line M. Mark a point Q on it. With any radius and Q as the center, draw an arc to cut line M at point R. With the same radius and R as the center, draw an arc to cut line M at Q. Mark the point of intersection of arcs as P. Join P to Q. Bisect the angle. Measure angles PQS and SQR. Angle PQS is equal to angle SQR is equal to 30 degrees. Construction of 60-degree angle. Draw a long line M. Mark a point Q on it. With any radius and Q as the center, draw an arc to cut line M at point R. With the same radius and R as the center, draw an arc to cut line M at Q. Mark the point of intersection of arcs as P. Join P to Q. Angle PQR is formed. Construction of 120-degree angle. Draw a long line M. Mark a point. With any radius and Q as the center, draw an arc to cut line M at point R. With the same radius and R as the center, draw an arc to cut the first arc at S. With the same radius and S as the center, draw an arc to cut the first arc at P. Join P to Q. Angle PQR is formed. Summary. Let us summarize what we have learnt. Construction of circles. Construction of line segments. Construction perpendicular to a line segment. Construction of a perpendicular bisector of a line segment. Construction of an angle bisector. Construction of angles.
Introduction. Hello children, you may have found that on folding or cutting some objects like blackboard, chalk, paper along a particular line, we get two identical halves. These objects are called symmetrical, and the line along which the object is folded is called the line of symmetry. Today let us learn more about symmetry. Objectives. At the end of this lesson, you will be able to define symmetrical objects, define line of symmetry, find the number of lines of symmetry in different figures, explain the mirror line as the line of symmetry, recall the applications of symmetry in daily life. Children, look at the rug. When you fold it, and right halves match each other. Thus, the rug is said to be symmetrical. Look at the leaf. On folding the leaf, its two halves match each other. Thus, it is symmetrical. Look at the touch-me-not plant's leaves. When you touch, it is folded in halves. Can you see the two halves matching each other? This particular line created by folding of the leaves is called the line of symmetry. This bug also has a line of symmetry along which it folds into two identical halves. Take a piece of cloth, fold it into halves. Now cut two small circles from the middle of this piece. Now after unfolding you can see a symmetric pattern that has a line of symmetry along which it can be cut to two identical parts. Manu and Mrinal have one rectangular cake. Each of them want exact half of it. The cake can be divided in two ways to give equal halves. Do you want to know how? Let us find out. The cake can be divided along the horizontal line so that its two halves match each other. It can also be divided along the vertical line, so the cake has two lines of symmetry